In the following example, we are asked to find sine theta in quadrant 4 for a given trig ratio cosine theta equals 2/3. Okay, so we've got a little bit of information that we've got to take a look at. Okay, so first of all, we've got cosine is 2/3. Well, think about it. In terms of sine, cosine, and tangent, we have so, ka, toa, we have cho, sha, cow. Well, cosine is the ka. All right, and in that case, that is going to be my adjacent over my hypotenuse. So A over H. All right, so let's think about this for a second. We've got this triangle right off here to the side, and this side, this angle right here is theta. So this is going to be the adjacent side, and this is going to be the hypotenuse. Okay, so let me go ahead and label that as A, and I'm going to call it 2, and my H, and I'm going to call it 3. Now, it's a right triangle, so all I need to do is the Pythagorean theorem to find the remaining side. And so in that case, it's simply going to be the square root of 3 square minus 2 square. And I'm going to get square root of 9 minus 4, which is the square root of 5. So, if I look at it here, the opposite side, let's call this one O, is going to be the square root of 5. Now, they want the sine. So the sine, as you might recall, is the so, right here. So, ka, toa, so. It is the opposite over the hypotenuse. So for me to write out the sine of theta, it is going to be the opposite, which is the square root of 5. Square root of 5 over the hypotenuse, which is 3. But now it's really important that we make note that they said they want this in quadrant 4. So then we have to refer back over here to the fact that all students take calculus. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. In quadrant 4, only cosine and its cousin secant are positive. Therefore, sine in quadrant 4 is negative. So the answer to this question is that the sine is equal to the negative square root of 5 over 3. Okay? So now's a good time to pause, maybe rewind if you need to rewatch that one more time. But otherwise, I'm going to move on to another example. Okay, so let's take a look. Give me 1 second. Okay, so here's another example. In this case, they want the cosine in quadrant 3, and they're giving us the sine of theta equal to 12 over 13. And I believe it's actually negative 12 over 13. So let's correct that. Negative 12 over 13. So, SOHCAHTOA, this is the opposite over the hypotenuse. So here's the angle theta right here. The opposite being here. Of course, this is the hypotenuse. And let me just go ahead and sketch in the right angle. And then we've got the opposite. We're going to call it negative 12. We're going to call this the hypotenuse of 13. All right. And we're going to find the adjacent side because the cosine, as you might remember, is the ka, the adjacent over the hypotenuse. So, again, a play on Pythagorean's theorem, 13 squared minus negative 12 squared. And that's going to be the square root of 169 minus, now just remember, this is where a lot of students make mistakes. They'll say a negative 12 squared is negative 144, and that's actually not right. It's just 144 positive. So you have the square root of 169 minus 144, and you get the square root of 25, which is relatively simple, which is 5. So the adjacent side is 5. All right. Now, what else do we need to know? Well, 12, 5, 13, Pythagorean triples, 5, 12, 13. That one was fairly simple. It works out. But let's see, they want the cosine. So the cosine of the angle theta. All right, and let me do my sketch here. All students take calculus. We are in quadrant 3. 1, 2, 3, 4. So go back to 3. In quadrant 3, only tangent and its cousin cotangent are positive. The rest are negative. So right off the bat, this makes our answer over here negative. And it's the opposite. I'm sorry, it's the adjacent over the hypotenuse because they want the cosine. So negative 5 over 13. So the cosine in this quadrant is going to be negative 5 over 13. And there you have it. So if you liked the video, if it helped you out, be sure you like and subscribe. Thanks a lot.